Hi, welcome to the video solution for physics. This is Edexcel IAL Physics Unit 1, January 2015, Part 2, question number 12. A bungee jump consists of three main stages. Free fall jump until the rope is straight, deceleration as the bungee rope stretches, upward motion as the bungee rope contracts. Complete the table to describe the energy transfer of the bungee jumper. Ignore any change that could be due to air resistance. So during a free fall jump, gravitational potential energy is converting into kinetic energy, and deceleration as the bungee rope stretches. So because you have a stretching situation and bungee rope is being stretched, so when something being stretched, that means elastic potential energy is stored. So when the bungee jumper is coming down, it has some gravitational potential energy and the kinetic energy, and both of these are converting into EPE. So you can say that GPE and plus some kinetic energy converting into elastic potential energy. And upward motion as the bungee rope contracts. So if it is contracting, that means elastic potential energy will be converting into GPE because it is going up, GPE, and of course some kinetic energy. So in fact these two, stretching and the contracting, these are opposite processes. So you can say that GPE and KEP and so on. So that's how you write. Part B, a bungee jumper of mass 54 kg is going to jump from a platform that is 65 meters above the ground. For the jump to be safe, his height above the ground must never be less than 10 meters. Show that the maximum transfer gravitational potential energy during a safe jump is about 30 kilojoule. Situation is, this is ground, and you can imagine this is a platform where a person jump, and the total height ground and the platform is 65 meter, and for the safe jump jumper should be 10 meter above till here. So clearly this height would be 65 minus 10, that means 55 meter. 55 meter is the total height including stretching and the free fall. So you can say that elastic potential energy or change in gravitational potential energy, so GPE is mgh. So mass is 54, g is 9.81, and height is 55. Change in height, if you solve this, you will get answer 29,135.7 joule. That means around 29 kilojoule. This is change in GPE. Hence, calculate the tension in the rope when the bungee jumper is 10 meters above the ground. Initial length of the rope is 23 meters. So you need to find the tension. So you know that you have already found elastic potential energy. So E is equal to half of Fx, and this F is in fact force, or you can say this is your tension in the string that causes the extension. So you can rearrange for the tension, or you can replace this F and T. So you can say that T is equal to 2E over X. E you have already found, 2 times of 29,000 kilojoule in a previous part, and the extension. So the total stretched length was 55 from the platform to the safe jump. This is the total length, and out of this total 23 was initial length. That means X is the extension, which is 55 minus 23. So 5 and 3, 2, 5, 3, so 32 meter. If you solve this, the tension would be 181, 2.5 Newton, and you can round it off 1813 Newton. This is the tension. Opposite poles of a magnet attracts one another. Using this principle, students try to using a toy car that could be self-propelled using a magnetic force. His design is shown below. Okay, magnet A and magnet B. Magnet A is attached to the body of the toy car, and the magnet B is suspended from the driver's hand by a rigid rod. Magnet A is identical to the magnet B. The student stated that as long as the opposite poles of the magnets are facing one another, the attractive force created should cause the toy car to start moving forward. Explain why in practice this could never work. In fact, what is going on in this question is student is thinking that because of the attractive force, the magnet A is going to attract towards the magnet B. That cause a forward motion of the car. That's the basic principle the student was thinking, but we need to see whether it is going to work or not. The idea is, because both magnets are identical, so magnet A applies force or attract magnet B, and due to Newton's third law, magnet B attract magnet A with the same amount of force. And the key idea is both forces are connected with the same body or same object. A is directly connected with the car, and B is connected with the car through the students. So both magnets are part of the same object. That means both forces will be acting in opposite direction and equal in magnitude. So net force will be 0. That means there will be no acceleration, and according to Newton's second law, the car will not move. So the reason is because both magnets are connected with the same object, and it's just my description that I'm giving. You can imagine you have a car, something like this, and this is the magnet A, and if you attach magnet B with some other object, and if you keep the distance between the two magnets same, so that both can attract, but both magnets are attached with a different object, so it is possible that the attractive force is sufficient to overcome the friction and the car A can move. But again, it is not a self-propelled. You need to use energy to move the second car. I hope you understand the situation. 14. A man is walking at a constant horizontal velocity of 1.2 meter second inverse in the rain. To the man, the rain appears to be falling vertically at the velocity of 1.8 meter per second. Draw a label vector diagram to scale and use it to determine the actual velocity of the rain. So it's all about vector addition and a scaled vector diagram. So you need to convert these velocities in centimeter, so you can draw a scale vector diagram. And if you take 1 centimeter equivalent to 0.2 meter second inverse, that means for 1.2 you need 6 centimeter long vector, and for 1.8 you need 9 centimeter. So it's, I guess, a suitable scale. So now what do you need to do? They are saying that the man is walking with the constant horizontal velocity of 1.2. So what I'm going to do, I'm going to use horizontal arrow to show the velocity of the man moving with 1.2, but for 1.2 I'm going to draw 6 centimeter horizontal vector. So I can say that let's say this is horizontal vector of man, and then for 1.8 meter per second, because the rain is seems to falling vertically, for the man the relative velocity of the rain is 1.8 meter per second vertically, and I need to add these two. So for 1.8 I'm going to draw 9 centimeter line, and remember I need to add these two vectors using head to tail rule. So I just need to, and this arrow now this arrow should be 9 centimeter long and something like this. This is 9 centimeter. So this is horizontal velocity of the man, this is a vertical velocity of the rain for the man, and for resultant velocity this will be your resultant velocity. So V. So V1, V2 and V. You need to find the resultant velocity. So from here you can use Pythagoras theorem, or you can measure the length of the velocity and you can convert this centimeter into meter second inverse using this scale that we chose, or you can use Pythagoras theorem and then convert the resultant velocity with this. So your magnitude of the velocity V should be around 2.2 meter second inverse. And in these types of question, most of the time we need to find direction in addition with the magnitude, and in this case the direction I'm going to find with the help of along the vertical line. So this is a vertical line, so I need to figure out this angle theta. So clearly this theta and this theta, this angle is same, so I can use tangent theta opposite over hypotenuse 6 upon not opposite over hypotenuse, opposite over adjacent. This is adjacent, so 6 over 9, and the angle will be equal to 33.69 and round it off to 34 degree to the vertical. 15. In a game of netball, a goal is scored when the ball passes through the ring at the top of the net. On the diagram below, draw the path of the ball should take if the goal is to be scored. So the ball should follow the path. It's a kind of it is a projectile. The ball should follow the path, so the goal is to be scored, something like this. B. A student is given the following information for a particular attempt at a goal. Initial velocity of ball on release equal to 4.5. Release angle is 60. Horizontal distance from the center of the ball is 1.5. Show that the time taken to travel the horizontal distance of the ball is about 0.7 seconds. So horizontal distance is given and velocity and the angle is given. In projectile, for horizontal distance, we always use equation for uniform motion, S is equal to ut. But remember, this u is not just a velocity given here, because it's a projectile. For horizontal distance, we use horizontal velocity, and this u should be horizontal component of the given velocity. That's u should be 4.5 cos 60. So S is given, which is 1.5 meter, equal to u is horizontal component, so 4.5 cos 60 into t. And if you make t as a subject, so you will figure out t as 1.5 divided by 4.5 cos 60, so t would be equal to 0.666 and 0.67 second. This is the time for the horizontal distance of 1.5 meter taken by the ball. Calculate the vertical displacement of the ball when it has traveled a horizontal distance of 1.5 meter, and hence comment on whether the goal will be scored or not. Vertical distance of the ring from release point is 0.7. So the idea is, you have a ring and this is the ball that you are releasing. So from the center of the ring to the center of the ball, this height is 0.7 meter, and we need to figure out if the ball is moving up. So if the displacement gained by the ball during throw is greater than greater than 0.7, so it is possible that we have a goal. But if it is less than, then it will not be a goal. So that means we need to figure out displacement or the vertical height gained by the ball. Again, so for vertical height in case of projectile, we use S is equal to ut plus half at square. In this case, this u is the vertical component of the velocity. So you can say that S is equal to 4.5 sine 60. This is the vertical component into time. Time we have already found, 0.67 plus half, and value of a, acceleration, so minus 9.81 because ball is going up, and then t square 0.67 whole square. If you solve all these numbers, then the height or the distance traveled, the vertical distance traveled by the ball is 0.41 meter. Clearly, displacement of the ball is less than 0.7 meter. So it will not be, the goal will not be scored. Explain how air resistance would have affected the calculation in BI. So air resistance generally, not generally, due to air resistance, we have a horizontal force acting on the projectile, and due to this horizontal force, we have a deceleration, and that causes a ball to take more time to reach the same distance due to deceleration. (16) Silk is a natural protein fiber produced by spiders and silkworms. It is a material of high tensile strength. The graph gives the stress-strain curves up to the point of fracture for silk produced by the spider and by a silkworm. So dotted line is for silkworm and the solid line is for spider. State what is meant by high tensile strength. So high tensile strength means a material can withstand against a large stress. So high tensile strength, it's a quite a strong material, can bear a large amount of stress. Spiders use silk to build webs to catch insects. Use the graph to explain how the properties of spider silk make it more suitable than silkworm silk for building webs to catch insects. Okay, so we see the graph. This is the graph of to compare. Now, if you see the graph, the spider silk graph is more steeper than the silkworm. That means it has a large limit of proportionality. So that means spider silk has a higher elastic limit than the silkworm silk. So higher elastic limit, that means it can bear a large amount of stress and can return to the original shape if it is removed. And then again, moreover, if you see, it has a high breaking stress, so it will high breaking stress means it will bear a large amount of stress before breaking compared to the silkworm. And even if you wish, you can talk about the toughness, because the area under the spider silk graph is larger than the silkworm. So you can say that the area is larger, so area shows the toughness. So spider silk is tougher than the silkworm, so absorb a lot of energy. So you can reframe your answer like this. Okay. Use graph to determine the Young modulus of the spider silk for a small stress. Okay, so we need to find the Young modulus from the graph, and it is a stress strain graph. So Young modulus is the gradient from a linear region, gradient of a linear region. So you can choose any one point in this linear region to figure out the gradient. So I can take this point, I guess. Let's see. if this is the point. Okay, for this point I have coordinate as 52 million Pascal. Okay, 52, 54, yeah, 52, and the extension is 0.005 times how many? 5, 6, and then 7. Yes, 7 times 0.035. So this extension is 0.035, and the corresponding extension here is 52 million Pascal, and this coordinate is 0, 0. So I can find the gradient. So gradient is 52 million Pascal divided by extension. Extension is 0.035, and the gradient will be 1.485 10 to the power 9 Pascal, or you round it off. So gradient or Young modulus is 1.49 into 10 to the power 9 Pascal, and 10 to the power 9, if you wish, you can say it is a giga. An insect flies into a spider web and becomes attached to a single thread. This creates a tension in the thread of 580 micronewton. The thread extends by approximately 3% of the original length. Calculate the radius of a single thread of a spider silk. Okay, so first of all, this is the force, and remember this is micro means 10 to the power minus 6. So this is a force acting on the silk. This is 3% of original length, so in fact this is your strain. So we have found Young modulus. Young modulus is sigma upon epsilon. So sigma is force upon area over epsilon, and then force upon a epsilon into Young modulus, because we need to find the radius. That's why we are doing all these stuff. If you're okay, see, this is just for your understanding. If you are okay with these steps, so you can skip some of the intermediate steps. So you can rearrange for A. So A is equal to F upon Y epsilon. That means area is force, and force is 580 into 10 to the power minus 6 Newton divided by Young modulus, and the Young modulus is 1.49 into 10 to the power 9 we have found in the previous part, and epsilon is 0.03, so 3%. So if you solve this, your area will be equal to 1.3 into 10 to the power minus 11 meter square, and then area is pi r square equal to the same number, and then you can figure out radius. Send pi on the other side, divide 1.3 with the pi and take the square root. So your radius should be 2.3 10 to the power minus 6 meter. Thank you very much for this part. Have a nice time.